Okay. So we're going to be learning about number sets today. So a number set, when you guys think of a set, what do you guys think about when you think of a set? When you think of a set, what do you guys think about? What do you guys think about when you think of a set? Shireen? Yeah, a group of things. What else comes to mind? Okay. So a set, like Shireen said, is a group of things. In this case, a set is a group of numbers. In this case, a set is a group of numbers. So simply, a set is a collection of things that share a certain property in common. So for example, I have a coat, a t-shirt, and a hat. That is a set. That may be something you find in your bedroom closet. You have a hand with the finger, so your hand contains a set of fingers. You have your thumb, your pinky, your ring finger, your middle finger, and your index finger. What else is an example of a set? Think about what you guys have on you right now in your pencil case. Crayons. What else? Pencils. What else?
Geometry set.
Geo set. Anything else? Pardon? Eraser? Yeah. Eraser, and etc. So we're going to learn something about finite and infinite. Are the sets that we just mentioned here, are they finite or infinite?
Finite.
Finite, okay. Now, Caesar, when you say finite, what would the definition of finite mean?
Something that ends, like you have to pass an admin.
Yeah, so it has a certain amount in that set. Okay, now what does the word infinite mean? What would an infinite set mean or be? Someone give me a definition for that. Aaron?
Never ending.
Never ending. Okay. So for set notation, we use curly brackets to list the elements of a set. So for example, if you want to list a set of, the people in your household, so like your mom, dad, brother, sister, you would use a curly bracket to represent that set. Curly brackets are sometimes called set brackets or braces. Each element in the set is separated with commas. Sometimes you'll notice that the set ends with 3 dots. These dots are called ellipses, meaning that they continue on for infinity. Okay, so for example, if I were to write a set for this class, I would write all of your names, separately, and that would be my class set. Okay, so I'd write, let's say Caesar. Let's just say my class had 2 people in it, or 3 people. Hey, Daniel. So if my class only had 4 students, my list would only contain 4 people. If I were to ask you how many elements are in the set, what would you say? How many elements would be in the set? 4, because there's only 4 people in my class, in my hypothetical class. In reality, I have, what is it, 27 of you, I think? 27. So if I were to ask you guys to name the set of video games you have, you probably have a finite amount of video games because you can't infinitely own many video games unless you have access to all of that. And yeah, for example, the amount of apps that you have on your phone, that is a finite set because you guys can probably name them off by heart. So be sure that you're copying this down. Are the numbers a finite or infinite set? Yeah. Yeah. There are infinitely many numbers in the real number system. So numbers are an example of a finite set because they can be going on forever and ever and ever and ever and ever. Just like pi. Pi has infinitely many decimal places after you write 3.14159. Keeps going and going and going. So the notation for the above examples above would be hat, dress, your t-shirt, etc. For your hand, you have your index finger, your middle finger, ring finger, and pinky finger. Notice how the first set has a ellipsis at the end, so the dot, dot, dot. This is because you can continue it as a set of things you can wear. So this is called an infinite set. So for example, if you have the three dots at the end, that you're telling me that your set is infinite. So this three dots over here means infinite set. So the second set is limited to those fingers because you end off with the bracket and there's nothing after pinky. So pinky, then the bracket ends it. So for example, A, B, C, D, ellipses. So we obviously know what's in the middle of the alphabet, X, Y, Z. Is that an example of a finite set or an infinite set? The letters of the alphabet. Okay.
Finite.
Finite because there are only 26 letters in the alphabet. So now we're going to get into the different number sets. So if I were to give you guys a set of odd numbers, what comes to mind? Set of odd numbers. What would the first odd number be? Lance? One, then what? Okay. 5, 7. Can I do what? Should I keep writing them, or would it just be beneficial to me to write dot 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 at the end? Because there are infinitely many odd numbers in the number system. Now, the set of prime numbers. Who can tell me the first bit of prime numbers? Lauren? 13. Yep.
Isn't 2 a prime number?
It's divided by itself and 1. Yep. So the set of prime numbers is infinitely many because we can have infinitely many prime numbers. Now, if I were to ask you of the multiples of 3 that are less than 10. So what are the positive multiples of 3 that are less than 10? There's only 3 of them. That means you're counting by 3. Shireen? 3, 6, 9. And because I only have 3 elements, this is a finite set. Which means that I'm only limited to those 3 multiples of 3 that are less than 10 because only 3 of them exist. Okay. So give me some examples of finite sets, like practical examples of finite sets. See what you guys can come up with. Practical examples of finite sets.
The amount of people in school.
Mm-hmm. Okay, what else? Any other examples of finite sets? Daniel?
The tables in this room.
Yep, tables in the room. And can someone give me one more example of a practical finite set? One more example. Let's see, one more. Practical example of finite. Shireen? Yep, pencils in pencil case. Oh my gosh, I can't spell pencil. Jeez. Now, besides numbers, are there any examples of infinite sets? Shireen? Pardon? I said besides numbers.
Oh.
Yeah. Besides numbers, what are some examples of infinite sets? Caesar?
Atoms in your body.
Atoms in your body. Let me Google that and see if there's actually a set amount. Yep, no, there's a finite amount.
Thanks.
Okay. Can you guys think of another infinite set? Whatever set you give me, whatever example, I'll enter it on Google and see if there's an actual number for it. Let's see. Daniel?
Stars.
Let's see. Oh, there's a number for it. So stars are a finite set that you can name. And I want to take another step. Gabe, are you thinking? Go all? It's hard to come up with something that's an infinite set because you can use the internet to figure out there's a maximum to a set. So like stars, there's apparently there's 200 billion trillion stars in the universe, so that is already a finite set. The number of atoms in your body, when I searched it up, it said there is a cap. There are 7 octillion atoms in a normal human body. So yeah, so there is a finite set of atoms in your body and stars in the universe. Okay, so whenever you think of an infinite set, always think about, is there always a maximum to it? If there is a maximum number of something, that means it's a finite set because it's capped at something specific. So now before I move on to the next thing, I'm going to write this word over here. Can you guys come up with a definition for that word subset? It has to do with sets. So what do you guys think a subset would be? Lauren? Okay, we have a set inside a set. Does someone else want to give me a definition? What do you think a subset is? Subset. What do you guys think of the word sub when you hear it? Miguel? It's fine. A set of sandwiches? Okay, I'll write that down. This is being honest, set of sandwiches. And I never gave you guys a definition, so for all you know, it could actually be a set of sandwiches. Never know. If it is, then good. Caesar?
Set of negative numbers.
So speaking of sandwiches, Subway or Mr. Sub or whatever other Subway. Or if you're bougie, you go to Firehouse Subs. Sub place. Any other examples of a subset, or what you guys think a subset is? Kobo? Set of bench warmers? Technically, he's not. It's actually a very good set of bench warmers. So by that he means like the players who substitute, they're just on the side. Okay. So set inside a set of sandwiches, set of negative numbers, and a set of bench warmers. Okay. I want to say Kobo was probably the closest one.
Is that with the reserve?
No, it's basically a subset is just a set of numbers that appear in like the original set. So technically they're like on the side kind of thing. So a subset is when we define a set, if we take pieces of that set, we can form what is called a subset. So for example, let's say my main set is 1, 2, 3, 4, 5, 6, 7, 8. Okay. My subset, can someone pick 4 numbers from that main set? Simon.
1, 2, 3, 4.
So my main set is 1, 2, 3, 4, 5, 6, 7, 8. A subset would be numbers that appear in the main set. So as you can see, in the subset, 1 appears, 2 appears, 3 appears, and 4 appears. And in the main set, I have 1, 2, 3, and 4. Okay? Because my subset contains numbers from the main set, it is considered to be an actual subset of my original set. Now, if I were to give you, let's say, a subset of, so let me give you another one. Is 1, 3, 5, and 10 a subset of my main set? Yes or no, and why? Aaron.
No, because 10 is in.
Yeah. So as you can see, 10 is nowhere to be found in my main set. So yes, 1, 3, and 5 are in the main set, but because 10 is not in my main set, 1, 3, 5, and 10 is not an actual subset of my main set. So they give us an example here. So I have the subset. So I have the set 1, 2, 3, 4, 5. So I just use more numbers in my example. So a subset of this can be 1, 2, 3, 3 and 4, or 1. The reason being is because all of these numbers in the subset appear to be in my main set. Okay. And then they give us the example of 1 and 6. The reason why this is not a subset is because 6 does not appear anywhere in 1, 2, 3, 4, and 5. Yes. Yep. So can you guys list other subsets of 1, 2, 3, 4, and 5 that are different from the ones above? Athalia mentioned one. 5 is one of them. Anyone else? So can you guys mention other subsets from the set mentioned above? So we have 1, 2, 3 as a subset, 3 and 4 as a subset. We have 1 as a subset. Athalia mentioned 5 because I have a 5 in here. 2. Okay, anyone else? Okay, give me a group of numbers. What'd you say? Yeah, that's fine. So I can have 2, 4, 1, 5, 3, 5, 2, 3, 4, 5, and so on. So when it comes to subsets, can we have infinitely many subsets, or is there a certain amount of subsets that we can have? Mm-mm. Subsets are finite. There can only be a certain amount of subsets that we can have before we run out of combinations. I'm starting to run out of combinations here. Can someone give me another subset that has not been mentioned yet? Lauren. 1, 2, 4. And someone, let's see if someone else can give me one last one. That has 3, 4. Nope, that's already mentioned down here, up here.
5, 4, 3,
5, 4, 3, 2, 1, or you're going backwards. Okay. So do you guys understand a subset now? Or not really? Okay, let me give you an actual set. So my set is 2, 4, 6, 8, 10, 12. I want you guys to come up with three subsets. Okay, Miguel gave me 1, 2, 4, 6.
separate.
No, we're not doing separate. That's cheap.
8, 10, 12.
8, 10, 12. Italia? Yep.
Could you also just like say 2, 8, 12
You can say 2, 8, 12. It doesn't have to be like,
in order?
yeah.
Then they have that.
2, 8, 12, 8, 10, 12, and 2, 4, and 6. Yep. Can you say that louder?
How are we going to use this thing?
How are you going to use this in math, like in the future? So, when someone asks you to list a specific amount of things, okay? So, for example, you can use this in Excel. Like, you can look up on Excel, like, arrange this in like a set so I don't have anything. Like, for example, in Excel, you can list things so that they appear to be in like one whole set together, so you don't have everything spread out. Okay, so this is more practical in the sense that it can help you when you're doing stuff on Excel or stuff with data. Okay, when you need to actually collect data information. But if you're not going to fields of data, that's fine. I still use this when I do my financial stuff. Okay, if I want a specific set of stocks to look at, I'll just look at the specific set of bank stocks. I'm not going to go out of my way to just Google each and every single one. I can just look up on Google set of bank stocks, and it will give me the set of bank stocks I can invest in, and then I can look at that instead of trying to search for each one separately. Okay, so you can use that for data analysis or data collection, but if you're not getting into it, you can probably use this more in the financial space as well. I'm going to get that question a lot. When can I use this in real life? When can you use geography in real life? You can. You can use geography in real life. Okay. Let me see how much time I got left. Okay. So take a couple seconds to copy this if you haven't. I know most of you guys bank on the filled notes already, so if you're copying, good. If you're not, that's okay. Uh, I just basically tell off of your quizzes if you guys actually do stuff at home, and for now, pretty good. So I'm not gonna be one to nag you to take notes. Yeah, we're gonna do Kahoot tomorrow with the review stuff. So we're gonna do a review sheet tomorrow, and then I'm gonna do a Kahoot because I already have it set up from last semester. Your test is gonna be next week. I just have to figure out how many days are left after Friday. So you have your quiz on Friday, and then I need to figure out a day for your Unit 1 test. Yep, we only have 2 more lessons left. Yep. No. Okay. So this you guys can go on after. It's like a link that takes you to like a specific page where you guys can do an interactive lesson with everything. It looks like this. Oh, it's not found. Wow, they took it down. Whatever. It's all good. C'est la vie. It's life. Okay. So we have natural numbers. So there are 5 or 6 different types of numbers. We have natural numbers. Can someone give me a definition of what natural numbers are? Think about when you count. What number do you start with? 1. So natural numbers would be defined as numbers you naturally count. So natural numbers are identified with the letter N. Now we have the set of whole numbers. So pretty self-explanatory, numbers that are whole. So no decimals, no fractions, nothing like that. Okay. What is different from whole numbers and natural numbers? What is the one difference? You can see it right away. 0. So whole numbers include 0. Nope, because you don't start by saying 0, 1, 2, 3. You start by saying 1, 2, 3. That's how you guys learned how to count in kindergarten. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or how many of you actually start counting with 0? No one?
What?
Oh, you start with 0?
That's what I told you. That's what you say here.
Okay. And whole numbers are represented by W. Integers, which is represented by I, are examples such as -3, -2, -1, 0, 1, 2, 3. What is different between integers from whole numbers from natural numbers? What is the main difference? Shireen? Yep. So this includes negative numbers. Okay. And that is represented by I. So rational numbers, which is Q, are numbers of the form A over B, where A and B have to be integers, and B cannot be 0 because we cannot divide anything by 0. So rational numbers, there's some conditions. It can be a decimal, okay? It can be a fraction, so like 3 over 4. It can be a negative number. It can be a whole number. It can be a decimal that has a repeating fraction or pattern. So for example, 0.33333, that continues. Another example can be 0.125, That is also an example of a rational number. Okay? I know these rules are pretty weird. Like I said before, BEDMAS was made by people coming together and saying this is how you do math. Exactly how the number system is made up the same way as well. So irrational numbers, we have the same letter Q, but it has a horizontal line on top. So it's any number that is not rational. So Q with the line on top are irrational numbers. So these are all non-terminating and non-repeating decimals that cannot be written in this form. So a square root 2, square root 3, and pi are not rational numbers because if you guys look up when you do the square root of 2, it doesn't give you a specific pattern when you calculate it. So I'm going to write the square root of 2 on my calculator, and it should give me a decimal that is non-repeating. Yeah, it gives me 1.41421356624 and so on. Okay, so the difference between rational is that there's either a pattern in the decimal or it's the same repeating decimal. It can be a fraction and whole numbers and integers. So remember, pi is 3.14159.246 whatever, and it keeps going on forever and forever. That is why it is considered an irrational number. As you can see, in the right up here, there's no pattern. And the real numbers are all rational and irrational numbers. So real numbers contain everything we saw in the groups above. So real numbers are irrational numbers, rational numbers, integers, whole numbers, and natural numbers. Okay. And last but not least, bar notation. So for repeating decimals, the period is a part that repeats, and the length of the period is the number of digits in the period. Okay. So we have a terminating decimal over here, so 0.5. That is the end of the decimal. And I have a decimal 0.12727272727. So the repeating decimal is 0.127272727, or it is written as 0.127 because the 27 is repeated. Okay. So the period, so what's the part that repeats? Yep, 27. And how many digits is in 27? 2. So that would be the period is 27. And then one last thing before I finish off is something called the empty set. So an empty set is where nothing is contained, okay? So according to math and the logic of it, an empty set, this is a subset of any set, okay? So the empty set is a subset of any set. So for example, if I have, say, the set 1, 2, 3, and 4, I can have a subset that is the empty set. Okay. So a subset, the empty set is always a subset with something. because it is considered to be a subset of itself. Since no set is a proper subset of itself, the empty set is always a subset of every set. You guys probably will never understand this. I have yet to fully understand this because logic is very weird. I've never had an answer that's satisfied my. I've never been satisfied by any explanation of why the empty set is a subset.
Wait, so what is an empty set?
Where there's nothing in it. An empty set is nothing. An empty set has nothing. That's what the empty set is. It has nothing. It has no elements in it.
So you're gonna ask for an empty set and then just put
Yep. That would be a subset. Is the empty set. Yep. Confusing. Pardon? If it's empty, because something can have nothing.
Okay, but then it wouldn't be in the subset because there's nothing from the set.
Yeah, which is weird because then it's still a subset because even though it has nothing, it doesn't not include anything from the set. That's the thing. Even though it's nothing, there's technically, so this means that even though I have nothing, it's not different from the set above. If I had 5, 6, 7, that would not be a subset. But because it's nothing, then technically, because there's nothing contained in it, I can say it's a subset of the original set. Because there's nothing there that is not contained in my set. It's a very weird explanation.
So would I put like nothing inside it?
Yeah. That would be a subset. Remember, the only way something is not a subset is if there is something completely different that is not included in the original set.
So we can't like put zero.
In this case, no, you can't put 0. But if you put the empty set, that's considered a subset. Yeah, weird explanation, eh?
Yeah.
Math is both confusing and easy and hard all at the same time. And to some people, it may be dumb, which is fine as well. Okay. So what you guys are gonna do now, I'm gonna give you guys the sheets to work on. Tomorrow, I'm gonna give you guys a review Kahoot and a review sheet for your quiz on Friday. Do you guys remember what your quiz on Friday is going to include? No, you guys don't pay attention to me? That's cool.